Hello students, welcome back to my class and let's start our today's science class. What can you see in the picture? Some symbols we can see that are indicating some explosive agents, some oxidizing agents or toxic agents. So all these are symbols, right? In chemistry also we have some symbols, that is the indications how we can learn about the chemical compounds. So our today's topic is experience 5 our laboratory, and we are going to study the topic rules for writing symbols, formulas of compound and molecular formulas. That is from session 9, and for this you have to read investigative studies book page 89 to 91, and the related topic is symbol, formula and valency, and along with it we will learn how to write the symbols, formula or valency. So let's get started. What can you see in the picture? What's this? This is hydrogen. This is the symbol of hydrogen, and you see here we have used the capital letter H. Now you see we have total 118 elements in our nature, and some of these are natural, some of these are artificial. And by using the short abbreviation or symbol, we can arrange these 118 elements in a table which is called the periodic table. You can see the 118 elements are arranged so beautifully here. Yes, there are some other characteristics to arrange these elements here, but in short we are writing the elements here by expressing with their symbols. Now look at the two pictures here. What is indicated by this one? Only hydrogen. And what is indicated here? What is this number? Yes, this is indicating that here we are having only one hydrogen atom and here we are having two hydrogen atom. So is there any difference between these two? Yes, this one, the right one, is called the formula or chemical formula. Like you see here, H2O, this is the formula of water. We are not saying that this is the symbol of water. Why? Because you see here in the let's get back to our previous slide. Here you see in the case of water we are having two elements here, and the H is indicating hydrogen, the O is indicating oxygen. That is, this is the symbol of hydrogen, this is the symbol of oxygen, and along with it we are having a number here 2, which is indicating here two hydrogen atoms are present. So that is the basic difference between symbol and formula. And this formula can be of two types. First one is called molecular formula, which will indicate one molecule of the substance. Like here C6H12O6 is indicating one molecule of glucose, C4H10 is indicating one molecule of butane. And you see here we can divide these subscript numbers 6, 12 and 6 by 2, and here after dividing the subscript numbers by 2, we can write it like CH2O that is called the empirical formula of that substance. So here is another type of formula, chemical formula, which is called the empirical formula. Molecular formula and empirical formula, and this empirical formula can be same to molecular formula in some case, because each time we can't divide the subscript numbers. You see in the next slide. Here again the example H2O, this the number here, the subscript number here H2, and here imaginary 1 here, so we can't divide these numbers anymore. So here the molecular formula and the empirical formula is same. So let's look at this slide. Again, the formation of H2O, we are getting 2 hydrogen atoms here and 1 oxygen atom here, and we are writing H2O, the molecular formula of water, and here H is the symbol, O is the symbol, but H2O is the formula. So H is indicating one element, O is indicating one element, but here H2O is indicating a compound. So can we say that symbol is only for elements and formula is for only the compounds? No, because here you see H2 is indicating the number of atoms here, 2 indicating the number of hydrogen, 2 hydrogen atoms here. So H2, this is formula of that element, but only H, that is the symbol of that element. So symbol is only for the element, and formula that can be for element or compound. That is the difference between symbol and formula. Okay, again you see here, let me rub the markings. Yes, how we are writing these numbers? Yes, we are saying that this is the number of atom, but from where we are getting this number, or how do we know that how many hydrogen atoms should be there, how many oxygen atoms should be there, or how they are forming the bond to form that water molecule? Is, yes, the answer is valency. What is valency now? Can you remember the previous class we did? In the previous class we have seen that sodium can donate 1 electron to chlorine. Again, chlorine, these can take 1 electron from that sodium. Okay, the number of donation or acceptance of electron here is 1. For sodium it's also 1, for chlorine it's also 1. This number of electron which can be donated from the sodium or the chlorine or any other elements, that is called the valency. Here you see again, in the outermost shell it is having 1 extra electron and it can be donated. After that the sodium is getting the configuration 2,8 of neon and it's getting the stability. That's why the valency here is 1 for sodium. Again for chlorine, it's taking one extra electron and it's getting the stability like argon and having the electronic configuration 288. So here the valency of chlorine is also 1. And what's in case of carbon? You can see in the outer orbit, outer shell, the carbon is having 4 electrons, 1, 2, 3, 4. So for getting the stability, it has to take 4 more electron, or it can share its 4 electron with other atom. That's why the valency of that carbon element here is 4. So that's how we are determining the valency of any element. Here you see the valency is actually calculated from the electronic configuration. Just look at the electronic configuration. What is the electron number in the outermost shell? Like the hydrogen is having only 1 electron, so it can donate only 1 electron or share only 1 electron. That's why its valency is 1. In case of helium and neon, these two are inert elements, and at the outermost shell it is having 2 electron, that is it is stable already. And neon also in the second orbit it is having 8 electrons and it's also stable. So they are not donating or accepting any electron, and they are inert elements, they are not reacting. Again, for lithium or beryllium or boron, you see the outermost electron that can be donated is 1 or 2 or 3, and the valency is 1, 2 and 3 respectively. Okay, so this rule remains like this up to carbon, where the outermost electron number is 4. But what's happening after the electron number is increasing above 4? What's about the nitrogen? It is having 5 electron extra, 5 electrons in the outermost orbit. In that case, it is not donating the electron. See here, the valency is 3. How is it? Because the nitrogen atom, which was having 5 electrons in the outermost shell, to get the stability, it takes 3 more electrons to get the stability, and it becomes it gets the electronic configuration 2,8 like neon. Okay, and gets the stability. So this is the rule. If the outermost shell is having more than 4 electron, more than 4 electron, then the formula is you have to deduct the number from 8. See, from 8 minus 5 is equal to 3. The valency is 3. So I am repeating again. If the outermost shell is having 1 to 4 electron, then the valency is remaining same. But if the electron number in the outermost shell is greater than 4, that is starting from 5, then we are getting the valency by deducting the electron number from the number 8, because the electron number 8 will give it the stability. So here you get today's CW. The questions here, wait a second. The questions here: what is symbol? Give example. What is formula? Give example. With example you will explain symbol and formula here. Then what is molecular formula? You can use any example of any compound to explain this molecular formula, and then you have to write the difference between symbol and formula. You will make a table. To write the difference. And then the question is valency. You have to explain the valency with any example you like. Okay, That's the classwork, and please do the classwork nicely in A4 size paper mentioning the day and date, and please submit it on the due date mentioned by the school authority. Okay, that's all. Thank you for today.